Hello everybody, welcome back. So we're going to finish this section on graphs of sine and cosine, and we're actually going to get down to the nitty-gritty and find out how to do these things, to draw these graphs without a graphing calculator. And it really just comes down to knowing what the amplitude is and what the period is. In particular, we're going to be we're only going to be concentrating on graphing functions of the form where y is equal to a times cosine of bx, or y equals a sine of bx, where a and b are constants. Okay. Then what we can do is we can, remember, if we add a number on the end, that corresponds to a vertical shift, and if we replace x with x plus or minus a constant, then there'll be a horizontal shift. Okay. But I want to be able to make sure that we can get these types of functions done first. So if you do it that way, then there's a very nice little way of doing this. First, you complete the amplitude and the period. So if you know what a is, just take the absolute value of a, that's the amplitude. And then 2 pi divided by the absolute value of b, that will be the period. Okay. So after we do that, on the x-axis we take the interval from 0 to 2 pi over whatever the absolute value of b is. This is going to, and then over this interval, we're going to graph one cycle of the graph. Okay, because we know that this is how long the length of this interval is equal to 1 period. So we divide this into four sub-intervals of equal length, and then we have 4 sub-intervals. That gives us 5 points, and then we're going to plot each of those points correspond to 5 x values, and we're going to compute their y values, and that'll give us 5 points. And that'll give us an idea of what the graph will look like. And then the last step is really just kind of broad. It says fill things in. Basically, you're going to connect the dots with some nice curves, okay, just by knowing whether the graph is a sine or cosine. Right, so let's look at probably the best way to do this is just to do some examples. So in this case, a is 2 and b is 3. So the amplitude is 2, and the period is 2 pi divided by 3. Okay, the absolute value is of a positive number. It's just that positive number. Okay, then we can draw our graph. We'll start by, in this case, we'll be going from 0 to 2 pi over 3. And we're going to break that into 4 subintervals. First, I'll cut this in half, and then I'll cut this in half. Okay. So we don't necessarily have to label all these points, but we can see that this is half of this, so this will be pi over 3, and half of pi over 3, this will be pi over 6. Okay, so this is, from here to here is pi over 6, this is 2 pi over 6, this is 3 pi over 6, which is the same thing as pi over 2. Okay. Alright, and then we can just go ahead and plot some points. So at 0 we get 2. So the first point would be when x is 0, we get 2, right? Because this is 2 times cosine of 0 is 2 times 1. Okay. Okay, then at pi over 6, we can plug in that in. We'll get 3 pi over 6, which is pi over 2. The cosine of pi over 2 is 0. So multiply that by 2, it's still 0. When we take okay, and then that would be that is that point, and pi over 3, multiply that by 3, you get pi. Cosine of pi is -1, multiplied by 2, that's -2. So that's point down here. And then for pi over 2, we got 3 pi over 2, the cosine of 3 pi over 2, that's 0, multiplied by 2, that's still 0. And then you can check that this last one, you'll get is 2 pi over 3. That's going to be the same as this one, so it'll be up here. Okay. And so now we can connect the dots, and we know what this is. It's not going to be like a nice line. It's going to be a nice curve, and it's going to behave like the cosine. So it's going to come down like this. Okay. So that represents one length, and then we can just go ahead and continue this, like so. Okay. All right, and really, I just want you to be able to draw one cycle. Okay, so let's look at another example. In this case, and maybe I should have set up here, A was 2, B was 3. That's how we did this. In this case, A is 4 and B is pi. So the amplitude is 4, and the period is 2 pi divided by pi. Well, that's 2. Okay. So in this case, the pi's go away. And so that's great. And so we want to graph from 0 to 2. Here's 1. Here's 1/2. Here's 3/2. Okay, and then we plot at these points. When x is 0, we get 0. When x is 1/2, we get pi over 2. The sine of pi over 2 is 1. 1 times 4 is 4. When x is 1, we get the sine of pi. That's 0. Times 4 is still 0. When at 3/2, we get 3/2 pi. That's -1 times 4 is -4. And then you can check that when you plug in x equals 2, you get 4 again. Or you get 0. You get, right, because the sine of 2 pi is 0. Okay. So you get this point. Here's 4. Here's -4. And so that's what one cycle looks like. Okay. Just like that. Down like that. Okay. Good, I hope. Let's look at something a little more interesting. Maybe. Interesting for some people. Now here, don't be distracted by this 5. What we're going to do is we're going to ignore this 5 until the very end. So we have constant. This is the same thing. Minus sine of 2x is the same thing as -1 times sine of 2x. So A will be -1 and B will be 2. Okay, and so the amplitude. That's the absolute value of -1. That's 1, and the period is, what is the period? The period is 2 pi divided by 2, which is just pi. Okay. Okay, and so now we'll graph from 0 to pi, and cut this into 4 intervals. Here's pi over 2. Half of that is pi over 4. And then you can check this has to be 3 pi over 4. Okay. And when x is 0, you plug that in here, and you'll get the negative sign of 0. Okay, so that's -0. That's 0 plus 5 is 5. Okay. Then we have, what do we have? We'll have pi over 4. Okay, so you multiply that by 2, and you get pi over 2. The sine of pi over 2 is 1. This will be -1 plus 5. that is 4. Okay. And then for pi over 2, plug in this, you get 2 times pi over 2 is pi, the sine of pi is 0, 0 plus 5 is 5. For 3 pi over 4, whoops, you plug that in here, you'll get 3 pi, that becomes 3 pi over 2, so that will be negative 1, but negative 1 times minus sign, that's positive 1. Positive 1 plus 5, that's 6. And then you can check that the next one at pi, this will be 5 again. Okay, so actually we want to go all the way up here, we'll make this 5. And so here's 5, and here's 6, and here's 4. So we have 6 here, 4. I'm sorry, it should be down here, we'll ignore that. Pi over 2 is 5. 3 pi over 4 is 6. And pi is 5 again. Okay, so our graph is going to look like this. Okay, so it's kind of exactly what we expected it would be. Or the amplitude is 1, right? So we know that this distance is 1. So this is a case where we won't have any x-intercepts at all, okay? Because we basically, this plus 5 shifts everything up 5 units, and then we can just continue this like so. Okay. Another one. Let's say look at y equals minus 3 cosine of 4x. A is negative 3. And b is 4. And so I will, let's see, the amplitude is going to be absolute value of negative 3. That's 3. And the period is 2 pi over 4, which can be simplified to pi over 2. Oops, I'm sorry about that. And we can cut this in half. That'll be pi over 4. Okay, half of pi over 4 will be pi over 8. This will be 3 pi over 8. And we plug in, say when x equals 0, this is negative 3. Then at pi over 8, we get sine, cosine of pi over 4 times pi over 8 is pi over 2, which is, cosine of that is 0. This will be 0. And check that when at pi over 4, you get that this is going to be cosine of pi, so that will be negative 1 times negative 3. So that will be positive 3. And then at 3 pi over 8, 4 times 3 pi over 8, that's 12 pi over 8. That reduces to 3 pi over 4. Or I'm sorry, 3 pi over 2. Cosine of that is 0. Okay, so again we have 0. And then you can check the last one is going to be pi over 2. Comma, well, we'll just plug that in, pi over 2, that's 2 pi, so that's going to be 1 times negative 3 is negative 3. Okay, so here's 3, here's negative 3, and so we, it will be like this. So here's 0, so it's going to come up like this, and down like that. Okay, and then you can fill this in like so. Okay, I didn't write it. I'm not writing all the arithmetic calculations because I want to clutter things up. Anyway, I will let you I'm going to pause the video and I'm going to let you work on example 5. Okay, so I'm going to take a moment and do this right now. Okay, hopefully got something like this. So the amplitude is indeed 2, b is -3, so the period is 2 pi over 3 again, and these are the same numbers we had in the previous example. And we just have to plug everything in here and be very careful. And we can see that we are, these are indeed the points, and there's difference. The minus sign is making all the difference here. So notice that even though the amplitude is 2, our range is between -1 and 3, and we're centered at 1 because from here to here is 2, and from here to here is 2. So hopefully you got that all right. By the way, this is supposed to be pi over 6 right here. Okay, great. Let's switch things up a little bit, and let's suppose we have the graph, and let's see if we can identify the equation that works. Okay, so let's say we have an equation, and actually we can figure out what the period is very quickly. We can see the period is 6 and the amplitude is 4. Okay, so that tells us that A, we can take A to be 4, or maybe it'll be -4. We'll see what we need. And B, we know that 2 pi divided by B, if we assume B is positive, this is 6. So we can multiply both sides by B, okay, and divide by 6. And then we get this is pi over 3 B. Okay, so let's see. Now the question is, what trig function will we use, cosine or sine? Well, we're starting up here, we're coming down, and we're coming up again. We're beginning and ending the cycle at the top, so it looks like this will be a cosine function. And in fact, it will be y equals 4 times the cosine of pi over 3 times x. Okay. All right, great. Let's look at this next one. Here we can see the period is, or the amplitude is 3, and the period will be 12 pi. So we can take A to be 3 maybe, and B, or 2 pi over B will be 12 pi, multiplied by B. Okay, divide by pi, or we actually divide by 12 pi. And this becomes pi over, actually the pi's cancel out. 12 cancel out here, and we get 2 over 12, which is 1/6. So it looks like B should be 1/6. Okay. And we are starting here, we're going down. Hopefully you see that this curve looks like, almost like it's a reflection of the sine curve, through the x. So we basically changed the sign of all of the y coordinates. So it looks like this looks like minus sine x. Okay, so we'll just say that y in this case is going to be -3 sine of 1/6 x. And you can check that works out. All right, let's do one more here. Here we have, well, looks like we have a different center center line here, right? This is sitting on the line y equals 1. The amplitude is going to be 3 again, and the period is 4. So we can take a to be 3, then 2 pi over b, we can take that to be 4, multiply both sides by b, divide by 4, and we get pi over 2 to be b. Okay. So it would be, looks like it might, this kind of looks like a sine curve, right? We shifted up 1. So it looks like y will be 3 sine of pi over 2 times x. Okay. That would be, this would be the graph if this graph were sitting, if this point where all these points were shifted down 1. But we basically shifted it up 1, so we're actually doing this plus 1. Okay. All right. And I think this looks like a good place to stop. Though again, practice, practice, practice. And we will see you next time. Thanks.